All right, we're going to be looking at a max height problem, and specifically a max height problem with free fall. So here on Earth, if you throw something up, it's going to eventually reach a maximum height. And the key idea when it reaches the maximum height is that the velocity is momentarily zero. Now, how do I know that? Because if it has a velocity that's positive on the way up and a velocity that's negative on the way back down, the only way to get from a positive number to a negative number is to go through zero. And so when it reaches that top point, when it has that zero velocity, it's switching directions. It's going from positive to negative. Okay? It's going from going up to going down. Right? So as soon as that ball leaves your hand, it's in free fall. It's only under the influence of gravity. We're going to ignore air resistance. So free fall, you might recall, means my acceleration is going to be negative 9.8 meters per second squared. Now the new thing for us here is that max height is telling me that at that maximum height, the velocity is zero. So my final velocity is going to be 0 meters per second. Now the example I have set up here is a person throws a tennis ball with 12 meters per second. They give it a good throw from about 1.5 meters off the ground. And I want to know how high does it actually get off the ground if I throw it straight up at 12 meters per second. So I'm in the vertical direction, so I'm going to use y's. My initial height is where the ball started. It left